Okay, so the liver, a very important organ in the body for a number of functions, and we're going to go through those uh, during this short lecture. So you should be familiar with this by now. This is the structure of the liver. You have these two lobules, and then you have this duct and portal system, these bile caliculi that then join with the right and left hepatic ducts, then joins with the cystic duct into the common bile duct, and then joins with the pancreatic duct to mix with the secretions that are then passed through the sphincter of Oddi into the duodenum. The contribution of the liver to digestion is through the release of these bile salts and bile acids into the lumen of the GI tract, and that is to help emulsify and digest the lipids that you take in. If we look at the structure of the liver in great detail, this is sort of the ultrastructure of the liver. You have these rows of hepatocytes that are opposite the sinusoids where sort of blood flows through, and then you have these bile caliculi that bile flows through at the end. You have then the central vein in the center, and then the hepatic artery and the portal vein on the outside. You need to be aware of the special blood supply of the liver, the fact that it gets its sources from two different places. You have the hepatic artery that brings in well oxygenated blood into the liver, but you also have this very large flow of deoxygenated blood that's rich in nutrients, especially after a meal, that comes from essentially the GI tract and mixes with the blood from the hepatic artery in the liver through the sinusoids that we saw in the previous slide. And this creates a generally lower oxygen content than the rest of the body, and this then has functional aspects to it. But it's a high flow system. You can see that there's about 2 liters of blood per minute going through the liver, but it's important to note that it's a low pressure system. The blood that comes through this portal vein, is at reduced pressure because it's already gone through the capillaries of the GI tract. And so even though it's high flow, it's low pressure. And this has implications then when the liver gets, uh, affected through pathophysiology, where the liver increases its resistance to flow, and this can cause backup through the portal vein, and is a major source of problems in liver pathology. Now you can break up the liver structure into both anatomical and functional liver units. The anatomical unit is the liver lobule, and it's the classical anatomical unit as we'll go over in the next few slides. But you also have then definitions of the portal lobule, which is defined by bile flow, and then the hepatic acinus, that is defined by blood flow. And I'll show you what I mean here now. So this blue hexagonal here is a liver lobule, and it has a central vein with 6 surrounding portal spaces, and these portal spaces contain 4 things: the portal vein, the hepatic artery, the bile caniculus, and the lymphatic vessels. And so it's known in the literature as a tetrad. Previous to this, the implications of the lymphatic vessel wasn't appreciated, and so if you go to old textbooks, you might even hear it called a triad. But that's no longer correct. It has lymphatic vessels in it, and it's known as a tetrad as a result. So here is some histology showing these hexagonal structures with the central vein and then these boundaries that attach to the portal space. And then if you look at the portal space, you can see the branch of the portal vein, the branch of the hepatic artery, the bile duct, and then the lymphatic vessels that make up the 4 points of the tetrad. So if we look then at sort of functional units, you have this portal lobule, which is defined as bile flow. And then you have this hepatic acinus, which is defined by its flow of blood. And you can see it has three zones. The zone 1 is closest to the hepatic artery, and so this blood tends to have the highest oxygen content to it. And then you can see that zone 3 is the furthest away, and naturally then it has the least oxygen content, and that means that the cells in zone 1, 2 and 3 do different functions based on the amount of oxygen they are receiving at the time. So zone 1, with the highest oxygen, are very active in gluconeogenesis and oxidative energy metabolism in mitochondria. And it's also the place where urea synthesis happens, because these are processes that need a lot of oxygen. And then zone 3, you're going to get glycolysis and lipogenesis, because these require less oxygen, or in glycolysis is actually an anaerobic pathway. And so you can see how the difference of oxygen concentration then determines how these hepatocytes function. If we look then at the differences in flow of the ultrastructure of the liver, we see that blood flow comes out from the hepatic artery and through the sinusoids towards the central vein, where it is then passed into the systemic circulation. Whereas the bile is created then in the hepatocytes and flows towards the bile duct for then passage into the GI tract. So the liver does an extraordinary amount of things for your body, but we've tried to put it into 4 categories so that it's easier for you to recall and remember. And these are energy metabolism and substrate conversion. It deals with all the materials that you ingest, and it creates substrates and energy compounds from this foodstuff that you take in. It has a synthetic function, creating a lot of proteins for a lot of different functions, some of those being transport. But the liver stores a lot of things in there, which we'll go into later. And it also has a protective and clearance function that is also very important. So going into these a little bit more, you have energy metabolism and substrate interconversion, and the liver deals with all the macromolecules, carbohydrate, proteins and lipids that come in through the portal circulation. It can create glucose. It's the main organ that modulates blood glucose, and that's because it can make it through gluconeogenesis or from the breakdown of glycogen. But it can also consume glucose and break glucose down into pyruvate and lactate, and it can also create glycogen from glucose as well. It also metabolizes a lot of proteins. It will break amino acids down and release the ammonium from it to create urea. But it also will make the non-essential amino acids de novo. Obviously you have non-essential amino acids that your body can make, the liver can make it because it has all the enzymes required, and then you have 9 essential amino acids that you have to take in from your diet because the liver can't make it, your body can't make it. And then lipid metabolism, the liver can create cholesterol, and it uptakes cholesterol and triglycerides from the blood and then puts them into chylomicrons and HDL and LDL. Obviously, the HDL is the good cholesterol, and then LDL is the bad cholesterol. And if you have high LDL, you have more risk at atherosclerosis. And not too dissimilar from, or there's aspects of a synthetic function we've already talked about, but The liver synthetic function not only deals with macromolecules, but also the synthesis of plasma proteins like albumin, clotting factors, angiotensin, etc., that the body uses for signaling growth. It will, as I said, create cholesterol and triglycerides, and then it's also very important in the synthesis and secretion of bile. Bile is secreted into the GI tract, and only about 5 to 10% of it actually leaves the body, but that's the only pathway out of the body for cholesterol. So, and then there's a transport and storage function. The liver is a very important source of glycogen. Glycogen in the muscle can't alter the blood glucose levels in your body, so that's left to the liver store of glycogen to regulate your blood glucose supply. And then it also is a very important place for the storage of iron being used for many things in the body. Your hemoglobin needs iron, but also your electron transport chain in your mitochondria needs iron, and a large portion of this is stored in the liver. Then it stores many of the vitamins we need. Vitamin A, D, E, K, and B are listed here. And then it's also involved in the transport of bile acids, as we saw previously in some of the secretion lectures. And then it creates a lot of binding proteins, particularly for steroid hormones and thyroid hormone. These are not water soluble, and so they need to be carried around the blood in transport proteins, and there are other molecules like transferrin that then will carry things like iron around. And then finally, it has a very important protective and clearance function. Your liver is your detoxification factory. As we mentioned earlier, it detoxifies ammonia through the urea cycle, so the breakdown of proteins will release ammonia, and then the liver will convert that to urea for excretion. The buildup of urea results in neurological damage, so it's a very important function. It's also involved in the metabolism and excretion of bilirubin, and failure of it to do this is seen in jaundice as you get increased breakdown products in the skin. And bilirubin comes down from the breakdown of hemoglobin. And then you have the transformation and excretions of hormones, drugs, and toxins. All the drugs that come in will get acted on by the liver. It'll get oxidized and then conjugated to glycine or glucuronic acid or glutathione for easier excretion and lowering the damage it does to the body. And then the liver also has a function in clearing bacteria. It has these Kupffer cells that are close to the hepatocytes that will phagocytose and endocytose pathogens and bacteria, damaged cells and things that are taken in through the portal vein. And so this gives you another aspect of GI protection. So the first is probably the stomach with the high acidity. The low pH in the stomach will kill a large amount of bacteria. Those that then get through the stomach and end up in the small intestine, there are secretions, and you have the lymphocytes in the GI tract that will work on many of the things that got through the stomach. But then if you have further pathogens that get into the portal supply through the lymphocytic barrier, the epithelial barrier of the GI tract, then the liver will be the third barrier through these Kupffer cells that will phagocytose and degrade harmful pathogens and antigens that are then taken in.